Welcome to Surds Level 2, one step in a level by level practice course. Pause the video now, try the problems on the screen, and I'll go through them with you shortly. At the end of the video, you can use the end screen to either practice more at this level or move up to the next one, and you can find topic by topic playlists on the channel homepage. In problem 1, we're simplifying the square root of 98 minus the square root of 50. Now, adding and subtracting surds is a lot like collecting together like terms. We need the surd parts to match to be able to add or subtract, and at the moment they don't. So what we need to try and do is simplify the two surds, make sure they have the same surd part, and then we can subtract them. So starting with the smallest surd, which is the square root of 50, we need to find two numbers that multiply to make 50, where one of them is on our square number list. And since 50 can be divided by 25, we can rewrite the square root of 50 as the square root of 25 multiplied by the square root of 2, because 25 times 2 is 50. Now, because 25 is a square number, we can square root it. So the square root of 25 is 5, so this becomes 5 root 2. We can now move on to the square root of 98. And we know from what we've done on the line above that this needs to have a surd part that has a root 2 in it. And because 98 divided by 2 is 49, this becomes the square root of 49 multiplied by the square root of 2. And because the square root of 49 is 7, this now becomes 7 root 2. So we can substitute these two values into our original sum. So the square root of 98 becomes 7 root 2. And we're going to take away the square root of 50, which is 5 root 2. And in a very similar way to 7x minus 5x being 2x, 7 root 2 minus 5 root 2 is 2 root 2. And this is our final answer to problem 1. In problem 2, we're simplifying the square root of 125 minus the square root of 45. Again, in order to subtract these two, what we need to do is simplify both so that they both have the same surd part. So starting with the smallest of the two surds, which is root 45, we need to split this into two numbers, one of which is a square number. And looking at our list of square numbers, 45 can be divided by 9, because 9 times 5 is 45. So we can rewrite 45 as the square root of 9 times the square root of 5. And because the square root of 9 is 3, this becomes 3 root 5. Now moving on to the square root of 125, we know that so we can simplify this, it must have a root 5 in it because of what we got on the line above. So 125 divided by 5 gives us 25. So this tells us that we need a square root of 25 in front. And since the square root of 25 is 5, this becomes 5 root 5. So going back to our original sum, the square root of 125 becomes 5 root 5 minus the square root of 45, which we can now write as 3 root 5. And since 5 minus 3 is 2, 5 root 5 minus 3 root 5 is 2 root 5. And this is our final answer to problem 2. In problem 3, we're simplifying 5 root 27 minus 3 root 48. Again, what we need to do here to subtract is first simplify each of the surds so that they both contain the same surd parts. And again, we're going to start with the smallest one, which is the square root of 27. Now again, to simplify this, we need to find two numbers that multiply to make 27, where one of them is a square number. And looking at our list of square numbers greater than 1, we can see that 9 divides exactly into 27 because 9 times 3 is 27. So we can rewrite the square root of 27 as the square root of 9 times the square root of 3. And since the square root of 9 is 3, this becomes 3 root 3. Moving on to the square root of 48, again we can use the line above to see that what we need here is to have a root 3 as our surd part. And because 48 divided by 3 gives us 16, this tells us that we must have a square root of 16 at the front, because 16 times 3 is 48. Now the square root of 16 is 4, so this becomes 4 root 3. Returning to the original sum, we have 5 root 27, so this becomes 5 multiplied by 3 root 3, minus 3 root 48, so that's 3 multiplied by, and root 48 becomes 4 root 3. Now simplifying these, 5 times 3 root 3 is 15 root 3, minus, and 3 times 4 root 3 is 12 root 3. Finally, because 15 minus 12 is 3, 15 root 3 minus 12 root 3 gives us 3 root 3. And this is our final answer to problem 3. In problem 4, we're simplifying the square root of 52 minus 2 root 117 plus the square root of 325. Now again here, to be able to add and subtract, we need the same surd part in each term. So we're going to simplify, and we're going to start with the smallest surd, and that's the square root of 52. So to simplify this, we need to find two numbers that multiply to make 52, where one of them is on our list of square numbers. And looking at our list, we can see that 4 divides exactly into 52, and that's the only number that does. So we can rewrite the square root of 52 as the square root of 4 multiplied by the square root of 13, because 4 times 13 is 52. Now the square root of 4 is 2, so this becomes 2 times the square root of 13, or 2 root 13. Moving on to our next surd, we have the square root of 117. And although this is quite a large number to break up, we know from the line above that we need a root 13 in there somewhere. So if we divide 117 by 13, we get 9. So this means that we have the square root of 9 times the square root of 13. And because the square root of 9 is 3, this is 3 root 13. We can do something very similar with the square root of 325. So we know that we need a square root of 13 in our answer, and 325 divided by 13 gives us 25. So this tells us that we need a square root of 25 here, because 25 times 13 is 325. Now the square root of 25 is 5, so this can be written as 5 root 13. We can now go back to our original sum and substitute in each of these. So we have the square root of 52, which is 2 root 13, minus 2 times the square root of 117, which is 3 root 13, plus the square root of 325, which is 5 root 13. We can now simplify the middle term, so we have 2 root 13 minus, and 2 times 3 root 13 is 6 root 13, and we have a plus 5 root 13 at the end. Now starting with the first two terms, 2 root 13 minus 6 root 13 is minus 4 root 13, and we still have a plus 5 root 13 at the end. Now minus 4 plus 5 is 1, so minus 4 root 13 plus 5 root 13 is 1 root 13. Or we can just leave this as root 13. And that's our final answer to problem 4.